Okay, today we're going to talk about naming chemical compounds. So, if we look at the periodic table right here, you can see that we have all the elements that we know about. So, we've got hydrogen, beryllium, and all that good stuff. But what we know the names of all the elements, but most of these elements in nature exist as compounds. So we're not likely to find, beryllium just hanging around by itself. It's probably going to find in some compound. So naming chemical compounds is really important. And we need to when we name compounds, we need to really think about what's important about the name. The name really needs to do two things. It needs to tell us, one, the types of elements, and the second thing is it needs to tell us the number of each element. Okay, so that's the important thing. So we want to know our name needs to tell us the type of element and the number of each element. So we have a couple general rules. We're going to start off naming what are called ionic compounds. And ionic compounds have uh, they're formed with a metal cation, okay, and that is the positive ion. And the cation in this case is always going to have the same name as the metal. So let's look at a simple one here. Let's say we want to write the name of this formula, LiCl. Well, this is the cation because if I go back to my periodic table here, it's lithium, and we know that these form +1 ions in this family, the alkali metals. And so that's my cation, and then my anion is going to be chloride. But the important thing is that the name, the cation in this compound is going to be lithium. And then if we go down for the anions, these are the nonmetals. These are what have negative charge. It's going to be, as opposed to being chlorine, we would say lithium chlorine, we're going to change it to lithium O R I D E. So we've kept the root here, chlor, and um, we've added this "ide" here at the end, and that helps us to make sure that we've changed the name to "ide" so that the correct name is lithium chloride. So you can see here, here's some common monatomic, just meaning one atom, negative ions. That's monatomic anions. You can see the hydrogen would become hydride, nitrogen would become nitride, and sulfur would become sulfide here. So let's try this. Okay, so here's the formula of a compound. Now remember, we want the name over here, we want to name it. We want that name to reflect the number and types of elements. So first of all, I want to show a little trick here. We're going to start off by writing the cations and anions, and this is going to help us later when we work from names to formulas. But let's think about this. Magnesium oxide. Okay, we got magnesium, we've got oxygen here. What's our cation? Well, we scroll back to our periodic table up here, and we notice that magnesium is in this family right here, which means it's going to be a +2, right? +1 and +2. This family is all +2. So we know that that is a Mg2+. And the anion in this case is oxygen. I'm sorry, so it's going to be oxide. And remember, these over here, this is -3, -2, -1. So oxide here is -2, so we're going to write O2 negative. And then the name is pretty simple. It's magnesium oxide. I didn't leave enough room in this table here, so I normally would write them just all out, but that's magnesium oxide. Okay, so let's try the second one. If we look at the periodic table, we'll find out that sodium is an alkali metal, so it's Na+. That's the cation. And the anion here is going to be N3 minus. Okay. Now notice here, there's 3 sodiums in this formula and only 1 nitrite. And the reason for that, if you think about it, is because sodium has a +1 charge. So ionic compounds always have to have a charge of 0, an overall charge of 0. So in this case, that's why there's 3 in this formula, because 3 at +1 and 1 at -3 is going to be neutral. But the name of this one is going to be sodium nitrite. Okay? Now, we're going to try one more, and then I'm going to have you finish the rest on your own for practice, and we'll check in. So this one is calcium. So calcium is an alkaline earth metal, Ca, and it's got a 2+ charge. And chlorine becomes chloride because it's a -1 charge, so chloride. And then our name is calcium chloride. Okay, so why don't you go ahead and finish those on your own. Go ahead and pause it and try the rest, and then we'll go over the answers. Now, in this example here, you're going to see that we're now trying to work backwards. We're trying to go from the name to the formula. And remember, a good name is going to tell us the number and types of elements. So in this case, we've got lithium bromide. Let's go back up to our periodic table here real quick. Lithium is in the alkali metals, and bromide is over here, and it is a halogen. All right. So we want to name this. So let's think lithium is a +1, bromide is a -1. So let's scroll back down to our table here, and we say, okay, so we know the cation is Li plus, and the anion in this case is Br minus. Remember, all ionic compounds have to be neutral, so we've got Li plus, Br minus, and the formula becomes LiBr. All right, in this next example, though, we've got sodium and we've got oxygen. So we need to go back to the periodic table, and we need to look and say sodium here is a +1. And you can see oxygen over here. That's in the -2 group. So let's fill in those ions right here. So we've got Na plus here, and here we've got O2 minus. So in this case, you see that the charge doesn't balance out because sodium is a +1, oxygen is a -2. So I'm going to need 2 of these in order to make this compound neutral. So I write that by saying Na2O, and I end up with sodium oxide. All right, now one more example here. This is magnesium nitride, and this is about as hard as these can get. We go back to the periodic table. We check on magnesium. It's 2+. Nitride over here, although this is a little bit more challenging. Nitride is a -3, so let's write those down here. We've got magnesium, magnesium is a Mg2+, and nitride is N3-. And if you think about these, the only way we're going to be able to combine these is if we have 2 of these, and if we have 3 of these. So then we get Mg3 and 2. Okay, why don't you try the rest, and then I will go ahead and hit pause and try the rest, and then you can check your answers. Okay, so you had pause. Now go ahead and check your answers. These are the answers to the first set that we did. You can see here they're in blue. Potassium iodide, strontium bromide, strontium phosphide. It's also important to know that these are not proper names, so you don't need to capitalize them. And then if we scroll down here to the last table, you can see that iodide's a -1, calcium's a 2+, so you have to have 1 calcium and 2 iodides. Calcium phosphide here, you've got phosphide at a -3, calcium at a 2+, so you need 3 calciums and 2 phosphides. And then finally potassium fluoride. Fluoride is a -1. Didn't show that there, sorry. And potassium is a +, and you end up with Kf. And that concludes the first lesson on naming ionic compounds.